everybody. So I just want to give you a quick demonstration to show what we mean when we're talking about the boundary of a surface and also the orientation, the connection between the orientation of the surface and the orientation of the boundary. So first of all, here I have a surface. It's a cylinder. You can see it's a cylinder. And this is my surface S, the cylinder. And it has a boundary. Up here, the cylinder is open, and at the bottom, the cylinder is also open. And so I drew in like a black line right here to indicate that this is part of the boundary curve. And then we have another piece right here in green. So both of those, so this green curve together with the black curve right here, are the boundary of our surface S. So in the workbook we're going to look at the same surface, and so we are calling the surface S, and then the boundary curve we're going to call that C. Now you know that a surface can have an orientation, and so here you can see my normal vector. I put in a normal vector. That little skewer right here is my normal vector pointing perpendicular away out from the surface. So this surface is oriented outwards, and I can associate an orientation of the boundary curve that is associated with the orientation of my surface using the right hand rule. So the right hand rule says you take your thumb, you point in the direction of your normal vector, and then you curl. Wow, that hand looks big. Okay, so then you curl, and then the way that you are curling right here tells you the orientation of my green boundary curve right here. So in what direction does it go? Well, it goes in the same direction as my fingers curl, and so I have a little arrowhead right here. Since my fingers are curling in that direction, the way that then my hand is pointing gives me the orientation of my boundary curve. So that's on that side. I can do the same thing on the other side. So now I'm interested in what's the orientation of that black curve. I do the same thing. My thumb is pointing upward. I'm curling my fingers around the vector. And so if I'm close to that curve, I can see that it's curling this way. And so if I put another arrowhead there, the orientation would be in that direction. So comparing those two, you can actually see that because of the right hand rule, one is pointing this way, one is pointing the other way. So one pointing away from me and the other one is pointing towards me. If my surface was oriented the other way, I did show that if you look inside here. So if the inside right there would be my normal vector, so forget the outside right here. If the inside was my normal vector, so if my surface was oriented inward, then that would change the orientation of my boundary curve as well. Okay, so that was example number one. I have one more example, and that is another surface right here, my metal bowl. It's another surface. Imagine this is surface S, and I put two possible orientations on it. So if it's oriented outward, right here is my normal vector. This is my normal vector pointing away. The boundary curve would be the rim of my bowl right here. This is the boundary curve C. And then again, I can orient the boundary curve using the right hand rule. So again, I'm pointing my thumb in the direction of the normal vector. I'm curling my fingers, and then in the direction that my fingers are pointing, that's where the arrowhead goes. So I have my boundary oriented that way, because that's the way that my boundary curve is, that my thumb is pointing up and my fingers are curling in that direction. I also put in the other normal vector. I mean, my surface could be oriented inward, so it's one or the other, right? It's not both at the same time. So if my boundary curve was oriented inward, it's a little bit harder to show, but I could still point my thumb, it's really hard to show, my thumb is pointing up, and I can still curl, and if I'm curling, my orientation would be going in that direction. Oops, the opposite. I lost my arrowhead. In the opposite direction. So it would be, I would be curling this way. You can kind of see what is happening. All right. See you in the workbook when we're going to look at the two-dimensional version of this.